This is section 2.6, combinations of functions and then composite functions. So our basic rules for combining functions are as follows, and they work exactly the way you hope they would. If you see something like f plus g of x, what that's asking you to do is to go find the function they call f and add it to the function they call g. If you're asked to find f minus g, you do the same thing, but you're going to subtract your two functions. If you see f g of x, you're going to multiply them. And if you see f over g of x, you're going to create a fraction out of them. Now notice right here that we have g of x not equal to 0. And that's because we are never allowed to divide by 0, ever. So we have to be aware of this. What we're going to be asked to do for these first couple of problems is we're going to be asked to find each of these, all four of these, and talk about the domain. Now, before we go on about the domain, right now there are really two things we have to worry about. We cannot divide by 0, so we're not allowed to plug in any value of x that would require us to divide by 0, this case right here. And also, we're not allowed to take an even root of a negative number. We're going to add more things to our requirements later, but for right now, that's all we have to worry about. Now, when we go to find the domain, we have to be aware of the domain of each piece that we are using and also the domain of what we get after we simplify. Okay, so let's just start off with f of x is equal to 2x plus 3, and g of x is equal to x minus 1. Now, before I start calculating all of these, I'm going to look at my two pieces. These are the two pieces I'm going to be using every time. And so if I look at the domains of these two, then I will be aware of what I'm going to have to include for all of them. If I look at f of x, I do not have an even root in here anywhere, so I don't have to worry about taking a root of a negative number. Also, I do not have a fraction anywhere in here, so I don't have to worry about dividing by a 0 either. The same thing happens here. There's no root, there's no denominator. So the domain for each of these individually is negative infinity to positive infinity. Or, in other words, neither of these causes a problem on their own. Okay, so let's go and find f plus g of x. This says I take f of x, which is 2x plus 3, and I'm going to add to it g of x, which is x minus 1. Now this is addition, and numerically, algebraically, the parentheses don't matter here. I use them so it's easier to see that I'm adding f and g, but since it's addition, they don't really matter. So just combine like terms. 2x plus x is 3x. 3 minus 1 is 2. So I have 3x plus 2. Now I look at this to see if I have any issues. I still do not have a square root or a fourth root or any other kind of even root. I still do not have a denominator. So there is absolutely nothing here that can cause a problem, either in either piece that we use or in the answer that we got. So this domain is all real numbers, from negative infinity up to positive infinity. Okay, so let's find f minus g of x. This says I find f of x, which is 2x plus 3, and I'm going to subtract g of x, which is x minus 1. Now this time the parentheses do matter because I have a negative 1 here that I need to distribute. So this is the same thing as 2x plus 3 minus x plus 1, which simplifies to x plus 4. Okay, now I need to consider the domain. I know that my two pieces are okay. I do not have a root here. I do not have a denominator here, so this is also negative infinity to positive infinity. Okay, so let's find fg of x. So that means I find f of x, which is 2x plus 3, and I'm going to multiply that with x minus 1. Now let's distribute, combine like terms here. That's going to be 2x squared minus 2x plus 3x minus 3, which simplifies to 2x squared plus x minus 3. Okay, now for the domain, again, I have no issues with either one of these individually. This does not have a denominator or a radical in it anywhere, so this domain is still negative infinity to positive infinity. Okay, now f over g of x. This will be 2x plus 3 over x minus 1. Again, individually, these do not have issues, but here I have something in the denominator, so I have to be aware of when x minus 1 equals 0. If you want to find the domain or what needs to be excluded from the domain, you set the denominator equal to 0 and solve. Well, that gives me x equal to 1. So my x cannot equal 1 here. So what does the domain look like? It starts at negative infinity, and it goes up to 1 using parentheses, meaning the 1 is not included, union 1 to infinity. It is negative infinity to positive infinity with a positive 1 taken out of the middle. Okay? All right, so let's do the same type of problem here. I have f of x is equal to 6 minus 1 over x, and g of x is equal to 1 over x. Let's look at the domain of these. Right here, I have an x and a denominator. I'm not allowed to have 0 on the denominator. Since here I had x minus 1, so I had some algebra to do here. But here, x cannot equal 0. It can't equal 0 here, and it cannot equal 0 here. Since these are the two pieces I'm going to be using for the rest of this problem, x can never equal 0, even if the apparent problem disappears. And you'll see what I mean by that in a second. Okay? So let's find f plus g of x. So that means I take f of x, which is 6 minus 1 over x, plus 1 over x. Again, the parentheses don't matter here. It's just because it's addition, it doesn't really matter. And what happens is that I have 6 minus 1 over x plus 1 over x. So these two cancel out, and I simply get 6. This is what I mean by the quote-unquote problem disappearing. The 1 over x disappeared. I have no problems with just a 6. But since I was using these two pieces that did not allow 0, I am still not allowed to have 0 here. So this domain is from negative infinity up to 0 with parentheses, so that 0 is not included, union 0 to infinity. So it's everything, we just have to take that 0 out. Now let's do f minus g of x. So this is f, which is 6 minus 1 over x. And now I'm going to subtract g of x, which is minus 1 over x. Now we have a common denominator here, so I can subtract across the top. I get 6 minus 2 over x. And that's simplified. Now I already know that x cannot equal 0, and I need to check to see if this added any additional problems, and it didn't. There's just simply an x in the bottom. A 0 still makes that a problem. So the domain here is still negative infinity to 0, union 0 to infinity. Okay, so now let's multiply them. Fg of x. So I'm going to take all of this and multiply it by all of this. This is essentially, well, it's one term. It's not a monomial because it's not a polynomial, but it's just one term. So we have a tendency to write those in front. But you know that f times g is the same as g times f because multiplication is reciprocal. Okay, so let's distribute. That gives me 6 over x minus 1 over x squared. So I have different denominators now, and I could get a common denominator here and combine them if you were asked to, and that would be 6x minus 1 over x squared. If you combine them, you could have gotten a common denominator here as well, but I just didn't. But the problem is I have an x squared, and what makes this a 0 in the denominator? is still a 0. Even though the denominator is different, the values that make it 0 did not change. So this domain still does not allow 0. Okay, now let's divide. F, G, and my brain left me, F over G of x is, I'm going to use a division sign here instead of doing it as a fraction, because I'll have fractions within fractions if I do that. This is the same thing as 6 minus 1 over x divided by 1 over x. Now, one of the rules that we have is that our g of x cannot equal 0. So I need to figure out right here if 1 over x, does this ever equal 0? Because if it ever equals 0, then I have a problem. Well, if I multiply both sides by x, I get 1 equals 0, which never happens. So 1 over x is never equal to 0. So that didn't add anything, any issue. Okay? Now let's think about what we know about dividing fractions. We keep the first one, we change it to multiplication, and then we flip the second one. So this is the same thing as 6 minus 1 over x times x, which is the same thing as x times 6 minus 1 over x. And then if you distribute, you get 6x minus 1. Now, did this add any additional issues? No, because there's no denominator here, there's no radical here. And again, our quote-unquote problem disappeared, but we still cannot let x equal 0. So the domain here is still negative infinity to 0, union 0 to infinity.